All right, so this set of notes is the beginning of chapter 3. So this is kind of the beginning of the unit on rocks. All right, so this first one, petrology, that's the specific branch or area of science that studies rocks. If you remember back at the beginning of the year, when we were talking about the different branches of science that go into Earth and space science, geology was one of them. And a lot of times people think that geologists, all they do is study rocks, which, some of them do, but we also learned that, geology is the study of the Earth, but petrology is the study of rocks specifically. And all rocks are is just minerals. That's all they are. So this picture is a good example of the different minerals. This is a kind of close-up picture of a sample of granite. But it's really easy to see the different minerals and the different crystals in that. And there was a picture similar to this in the video, but you can see, there's some pink crystals, there's some black crystals, there's some white crystals, and those are different minerals. So it's really easy to see that, it really is just a bunch of different minerals. And then on kind of a side note, this isn't anything, but off of the same root of petrology, we have another word, petroglyph. Just any sort of cave drawing or cave painting, ancient cave paintings or drawings are called petroglyphs, but that's from the same root as the petrology, since that has to do with, studying rocks, and this is, writing and, carving on rocks. So fun fact for the day, impress your friends and neighbors. All right, so the rock families, there are 3 of them. I'm guessing most of you have already been introduced at some point in time. We studied minerals, and minerals were classified a certain way. Does anybody happen to remember how minerals were classified? It was based on their what? If you're trying to classify a mineral. You can just say it or throw it up in the chat or whatever's clever. Anyone? Starts with a C. Then there's an O. And then an M. And then a P. It's computer. Now, composition. So when we classified minerals, we based that off of their composition, so what they're made up of. Rocks, we put those into different families based on how they form. So these are the 3 rock families, 3 rock types: igneous, sedimentary, metamorphic. Like I said, I'm sure you're all aware of this. And this will be the order that we're going to study these and go over them as well. We'll go over the igneous rocks first, then sedimentary, then metamorphic. All right, so igneous rocks. Igneous rocks form when magma or lava cools and hardens. So one of the things that all igneous rocks share is that at one point or another, they were all heated to the point where they became liquid. They were all molten at one point in time. It doesn't matter if they were, on the surface of the Earth or if they were, below the surface and underground. At some point, they were liquid. And here, this is obviously on the surface, this lava. Some of it is still liquid, but the crust that's forming on the surface, that's brand new igneous rock. I mean, it's just formed, just then as it cooled and hardened and crystallized. So then the next type is sedimentary. So there are several different types of sedimentary rock that we'll talk about, but kind of the stereotypical, the one that you kind of think of, the most basic kind and the most common, is made up of other pieces of other rocks, and they get cemented together in layers. And layers is a key term, a key concept for sedimentary rocks. It's how they form. You have a layer of sediment and then another one on top of that, another one on top of that. In this picture, it's a good example of different layers in this example that are very different, which is not usually the most common thing. But at the base and the bottom, you have what looks to be fairly sandy, and then above that you have that thin layer of compared to the other stuff, really large pieces of rock. And then above that, you have kind of a layer that's kind of a mix. And at the very top, you have the sediment would be very fine. So that would have been, silt or clay or mud, but it's very, very small pieces of sediment compared to that, that thin layer where it's, really big pieces. But like I said, layers is a big thing with sedimentary rocks. Plus, it's a quick and easy way to identify sedimentary rocks. If you see pictures of the Grand Canyon and things like that, where you can see layers and layers and layers, that's going to be a sedimentary rock. If you're going to have sedimentary rocks, you need to have sediment, and in order for that to form, you have the process of weathering. During the process of weathering, rocks break down into smaller pieces. So big rocks break into smaller pieces. Any size rock breaks down into smaller pieces. So if it's a boulder, if it's a piece of gravel on a driveway, if it's a mountain, there are processes going on in the environment 24/7 that are breaking down that rock. And with that process of weathering, the main components are weather. Anything that's weather. If it's rain, if it's snow, ice, hot, cold, wind, all of those things play into breaking down rock and how quickly that happens. If a rock is in an area where there's really only one dominant type of weather, for example, a desert, where it's pretty much either hot or cold all the time. The water, there isn't any rainfall, there's no snow, that sort of thing. There's not going to be as much weathering as compared to a place like here, where it'll rain and it'll be dry, and then it gets hot for a while, and then it gets cold. The number of changes in weather really speeds up how quickly rocks break down. And when it does break down, the result is sediment. It's the pieces that those rocks break into, and kind of and that's how they end up. That's what most sand is. That's ancient mountains that have weathered and eroded over hundreds of millions of years. But now that's all that's left of it is sand. So that's the sediment that's a result of weathering. And then we go to metamorphic. So metamorphic, something that you start with rock. It's not like a brand new rock is produced, but you start with a rock that's there. Something happens to it. Typically it's heat and pressure inside the earth, and then it changes the rock. So then the resulting rock after that heat and pressure, that's a metamorphic rock because it's been changed. I include this little diagram with the caterpillar and the butterfly. That's the process of metamorphosis. You remember back to biology. I know everyone has slept a few times since then, but it's the same concept. It's, you know, it's starting as one thing and it's going through a change and it ends up as something else. Granted, these rocks aren't going to fly away and all that, but they undergo a change. And that's the main thing. Kind of the key word with metamorphic is change. And that pretty much sums it up in the process of metamorphic rock formation. And then we have a real basic rock cycle diagram. I'm not going to go over the rock cycle much now. We'll go over that more once we cover each of the rock types. But I at least wanted to have this up here. There was some mention of it in the video yesterday, I guess. But essentially, the rock cycle is showing how any type of rock can become any other type of rock. You know, it just depends on what happens to it. And something to remember with you know, rock cycle and any sort of, you know, geologic process is it's really slow. It takes a long, long time. And we as humans, I mean, we're here for, you know, I don't even know what the average age of, you know, somebody in the US is, but, you know, compared to the age of the earth, I mean, it's nothing. I mean, it's a blink of an eye. So we don't really see these changes, but they are happening and they do happen over time. So then on to the last one. All right, so all of these things, you know, these processes that form rock and change rock and all of that, there has to be energy. It doesn't just happen without energy. I mean, nothing happens without energy. Some things just take more energy than others. You know, but this rock that's on my desk, it's not just going to spontaneously melt. I know that because there's not enough energy for it to. If there were, I would be in a lot of trouble because I'm right next to it and that would be a lot of energy. But there are only two places that all the natural processes on Earth can get energy from. So the first one is the energy source for things like it says here, you know, igneous rock formation, metamorphic rock formation. It's also responsible for volcanoes, earthquakes, you know, continental drift, all of those things. And that's the Earth's own heat. Again, I know we've slept a couple of times since then, but the Earth Layers project, the interior of the Earth is really hot. You know, some of that heat is left over from the initial formation of the Earth. So, you know, just like if you take the, you know, Hot Pocket out of the microwave, just let it sit there for a while. Let it cool down a little bit because it's still going to be hot on the inside for a while. So from the Earth's formation, since the Earth is way bigger than a Hot Pocket, it's going to stay warm for a lot longer. And then the other source of the heat is from radioactive materials in the Earth. They're giving off radiation, and that's heating up the Earth as well. So for the Earth's internal heat, remember some of that comes from the heat of formation when the Earth first formed, and then also from radiation from radioactive materials that are, you know, naturally in the Earth, not like nuclear waste and all that stuff. This stuff that's, you know, been there from the start. So that's the first source of energy, and that's what's responsible for. You kind of think of it as driving the processes that are in the Earth. But as far as things that happen on the surface and in the atmosphere, does anybody have an idea about the other source of energy that would drive those processes? Think about something that could be an energy source for something as large as a planet.
The sun.
Good. Yeah, the sun. So the energy from the sun is what's going to drive all the natural processes on the surface and in the atmosphere. And because this is kind of a chain reaction here, because the sun is providing the energy that creates, weather systems and, differences in pressure in the atmosphere, which then leads to things like wind, which then, all of those things create weather. And then that weather helps to weather and break down rocks, which then, produces sediment. And then that sediment can be turned into sedimentary rock. You kind of see where I'm going here. There are a few steps there, but it's on the surface. So the sun is going to be effectively responsible for providing that energy, because it is things on the surface and then things in the atmosphere that are going into the creation of sedimentary rocks. But those are the only two places that the earth and all those natural systems get energy from. The earth's internal heat and the sun itself. So does anybody have any questions, or are there any slides that I need to go back to?